Hey guys, so we are going to kind of transition. Up till now, we've been looking at what a matrix is and how to do different operations with it. And now we're going to start to apply matrices and see how can matrices be used other than just displaying data. So for example, today we're going to look at geometric transformations. We're even going to extend operations with matrices into solving systems of equations. So that lesson hasn't gone away. It's still a thing. But for today, we're going to look at how matrices can help us with geometric transformations. There are going to be a lot of quote unquote formulas, but they're nothing that you have to memorize. Everything that you need is in the book. And then whenever there's a quiz or a test, I will give you a cheat sheet with those formulas on them. So don't feel like you have to memorize these. But just let's review first from geometry. What is a transformation, an image, pre-image, dilation? These are all words that you should remember from geometry, but just in case, I've given you some definitions here. So a transformation is simply any change that's made to a figure. Any change we make is a transformation. An image is the transformed image, and the pre-image is the original figure. So pre means before, so it's before we move it. The image is what comes after we move it or change it. A dilation is when we change the size of a figure. So for example, if you start out with like a triangle like this, a dilation would be you could make it bigger, but it preserves the same like ratios in the triangle. You could also make it smaller as long as, again, you're preserving the ratios and the angles and all that. So hopefully that's a good quick refresher. Let's dive right in. So a quadrilateral has the vertices A 4, 3, B negative 2, 7, C negative 3, negative 5, and D 0, 1. It says to use a matrix to find the coordinates of the vertices of the image when it's translated 3 units to the left and 2 units up. So what we're going to do is display our original points in a matrix where the top row is X and the bottom row is Y. So I'm going to put all my X coordinates going across the top. 4, negative 2, negative 3, 0. And then I'm going to put my Y coordinates underneath. 3, 7, negative 5, and 1. And it doesn't matter actually what order we put these in. I just put them in the order that they were given to me. What matters is that when I read each column, they should match. So I have like 4, 3. So in this first column, I have 4, 3. For this one, I have negative 2, 7. And in the second column, I've got negative 2, 7. So each column should be an ordered pair. Now, they've asked us to see what are the coordinates if we translate left 3 units and 2 units up. So we are going to do an addition, and we're going to say, okay, what do we have to do to the X coordinate to translate 3 units to the left? What operation do we do to each of the values of X? We need to subtract 3 from each value. So we're going to put a matrix. It has to be the same dimensions, but we're going to put negative 3 in the first row. And in the second row, we want to translate it up 2 units. So what operation do we do there? We're going to add 2. So I'm going to put plus 2 all the way across. Now, when I add these together, I'm taking each X coordinate and shifting it to the left 3. I'm taking each Y coordinate and shifting it up 2. And so my final answer would be 1, negative 5, negative 6, negative 3. And then in the second row, I would get 5, 9, negative 3, and 3. And those would be the coordinates of my new image. So let me graph this like it asked me to. I've got 4, 3, and that's A. B is negative 2, 7. C is negative 3, negative 5. And D is 0, 1. So when I connect those points, well, this was D, C. Now I can graph the coordinates of my new matrix, and it's at 1, 5, negative 5, 9. Oops, that's negative 7, sorry. There we go. -6, -3, and -3, 3. And what should happen is it, even though I messed that up right there, it should look exactly the same. It should look like I just picked up the red shape and moved it. And that's what happened. So this would be A prime, B prime, C prime, and D prime. All right, so a quadrilateral has the vertices, etc. Use a matrix to find the dilation of 3. So what do you think we're going to do with a dilation of 3? I'm going to start by writing my matrix the same way that I set it up before. Now I need to deal with this dilation of 3. And a dilation of 3 means that each of these values needs to be multiplied by 3. So what can I do to this matrix to multiply by 3 for each of those? I'm going to do scalar multiplication because I want to distribute it to everything. So when I do that, I'm going to get 12, -6, -9, 0, 9, 21, -15, and 3. And this one we don't have to graph. That one would go quite a ways off the graph. You see we've got points like -6, 21. But I wanted you to see how we can use matrices to find dilations. So these are in your book, and again, you'll get these for quizzes and tests, but we are going to use matrix multiplication to graph reflections in the coordinate plane. The important thing to remember is that the matrix that you're given here goes first, and you're going to start to see a pattern. So we have our vertices, and we are being asked to reflect the quadrilateral over the y-axis. So I'm going to find the proper matrix. It would be this first one. And we are going to multiply these together. Now, I told you guys before that when you have zeros, it's a really great thing. Having ones is also a good thing. Let's multiply this and see if we can find what's happening. I'm going to take the first row times each column. So when I take the first row times the first column, I get -4 plus 0, because 0 times 3 is 0. So that's going to give me -4. First row times second column will give me +2 and then plus 0. And then I'd get 3, and then I'd get 0. Fill in that bottom row and see what you get. Hopefully you got the same thing I did. If you didn't, you can pause this and see where you made a mistake. But what do you notice about the matrix with the ordered pairs compared to our answer? Notice that like the first row was just changing the signs, and the second row stayed exactly the same. And this is the rule with reflections. It's that when you reflect something over the y-axis, you just do the opposite of x but leave y the same, and they stay in the same order. So the matrix helps us write that rule just in a way that we might not have thought of it. And if you have trouble visualizing this, that's okay. But I do think it's an important thing to see how matrices can help us. So when we graph our original shape and then we graph the reflection, it's going to look like this. -4, 3, 2, 7, 3, -5. Oops, I did 3, 7. There we go. And 0, 1. And what we see is that each of these points got reflected across the y-axis, and that's exactly what was supposed to happen. So set this one up and tell me what matrix you get for your final answer. All right, you can check your work here with the matrix and also with the graph. Remember that the line y equals x is a line that goes through the point 0, 0 and has a slope of 1. So I kind of drew that on there just so you could kind of picture the reflection. We can see that point A reflected across, point B reflected across it, D and C. And so drawing it is a really good way to help us visualize. So those are with reflections. We can also use rotations. And again, these are in your book and you don't need to memorize them. So we're going to set up this matrix first based on the vertices. Now, because I'm doing a rotation of 270 degrees, we are going to put our matrix over here, and we get 0, 1, -1, 0. Multiplying these together, for the first row, I get 0 times 4 plus 1 times 3, and that's 3. 0 times -2 plus 1 times 7, which is 7. 0 times -3 plus 1 times -5, that's -5. 0 times 0 plus 1 times 1 is 1. And I'm going to do the same thing for the bottom row. And what I notice here is that there was a 1 here, and I have the same exact values. Now I've got a -1, and it's in the first place. So what's going to end up happening is I'm going to get this first row, but with the opposite signs because of that negative sign. All right, graphing it, I'm going to have 4, 3. There's D. Connect our points. Okay, so when I graph these other points, we get 3, -4, 7, 2, so that was A prime, B prime, C prime is at -5, 3, and D prime is at 1, 0. So it's going to look like this. And I'm kind of thankful for matrices in this case because I have the hardest time picturing rotations. Those are the hardest for me. And so having a matrix to help me rotate around the center or around the origin is just super helpful. So that's what I've got for you. If you have any questions, let me know. I hope that this is something that does not stress you out because, like I said, you don't have to memorize these, but rather I hope it helps you to see, oh, matrices have some really important value in helping us to move on and to do things well. Like I said, let me know if you have any questions.